Before I start the next idea, I would like to present an idea. When you have two segments, there are times where you may have to add the segments together. Now, with the segments here, I have algebraic expressions, so it's just a matter of adding the expressions. It is true that sometimes you have to subtract them, but for right now, we're just going to worry about the addition. So when I look at this first example, this first idea, it says 3k minus 5 plus k plus 9. You combine like terms, and you could say that the big section all together, both segments together, would be 3k plus k, which is 4k. And then negative 5 plus 9 would be plus 4. That would represent the distance from here all the way to there. Second example of this, we've got 7w plus 11 and w plus 4. If I add the like terms together, 7w and w would produce 8w, and then the 11 plus 4 would be plus 15. This may be an idea that you're going to have to use in the next couple of examples. As we move to the second example, we see this great big picture. What you need to do with this type of problem is make sure that you understand that they're similar triangles and set them up as such. First thing I'm going to do is actually write what's similar. I'm going to say triangle ABC. ABC. Similar to triangle. Now I have to go in the same orientation, and when you have these converging triangles, they're facing one another, really what you're looking at is taking the smaller triangle and switching it out, flipping it the other direction so that you have one big triangle versus one small triangle, both oriented the same way. If I take this nose of the triangle and flip it over to the other side, this would become E, F, and what was originally pointing to the left is now going to point to the right. I'm going to call it D. And so I would say this is similar to triangle EFD. You may want to draw your pictures. I wrote the statement here, but you want to draw your pictures so you have big versus little. If I draw that, and it doesn't have to be anything huge, just enough that you don't get confused who or what you're working with. In this case, I have this AB here, which is 9w minus 2. And I have this EF, which is w plus 5. And then I have the two bases. The base for the big triangle was 25. The base for the smaller one was 15. On this type of problem, I don't have to set up two proportions, but moreover, I'm looking to solve for w and then come back and supply the values so I could find the missing lengths for each side. And so there's really only one proportion you want to set up here. You want to say something like 9w minus 2. See, vertical is to horizontal, as vertical w plus 5 is to 15. And then we can solve that. Again, I'm not interested in figuring out what the common denominator is as an exact value. I'm just going to take both parts. Using that calculator, I can let that work itself out. I can say, let's go 25 and 15. As I distribute, for the first fraction, the 25's drop out, so I'll have 15 times 9w minus 2 equaling. For the second fraction, the 15's can drop out, and I would have 25 times w plus 5. The downside of just taking those numbers, you may distribute, you may end up with larger numbers. I don't think it's the end of the world because we have calculators, and so you might as well use the calculator. I'll go 15 times 9. That gives me 135w minus 15 times 2 is 30 equals, as I distribute this, 25w plus 125. And then we solve like we always do. I'm going to move the 25w to the left and 30 to the right. So this would be 135w, take away 25w, equals 125 plus 30. And so that would be 110w, equaling 155. I'll have to squeeze that in there. As I move over, I'm going to divide both sides by 110. So 155 divided by 110. I get an answer that looks like this. I want an exact answer, so I'm going to convert that into a decimal, or from a decimal to a fraction, just by hitting the second and then the PRB button where it says F to D. As I hit that, I get 1 and 9 over 22. So W equals 1 and 9 over 22. That's nice that I have an answer there, but the problem is I need to know the lengths of these sides. So right beneath this, I'm going to say 9W minus 2 is equal. I want to know what the length of that is. And so you can take that answer times 9 and then subtract 2. I get an answer of 10 and 15 20-seconds. 10 and 15 20-seconds. Again, I have to go back and use this one. Now, this one I could probably figure out in my head. That's not too hard. If it's W plus 5, when you add 5 to this, it's going to be 6 and 9 20-seconds. That's how I would find those missing sides.